So, good day, everyone. Welcome to this lesson on instrumentation and control. So, for this first lesson, an introduction to industrial instrumentation. So, ano bang mga matututunan natin dito sa lesson na to? First, I will introduce you to the topic of instrumentation, and then I will give you a couple of examples. Ano ba yung mga pinag-aaralan natin dito? And yun, ano yung mga mini-measure natin at kinokontrol natin. Okay? So, let's start. Ano nga ba ang instrumentation? Okay? So, in simplest terms, instrumentation is the science of automated measure and control. Sabi nga ni Tom DeMarco, you cannot control what you cannot measure. So, applications on this science abound in modern research, uh, industry, and everyday living. So lahat yan, meron niyang instrumentation somehow. From automobile engine control system to home thermostats to aircrafts and to the manufacturer and pharmaceutical. So lahat yan merong instrumentation or minsan term natin is automation. So yung first step sa pag-aaral ng instrumentation is actually measurement. No? We cannot manage or we cannot control what we cannot measure. So, importante na i-point ko sa inyo na importante ang measurement. Okay? So, ano ba yung mga bagay na mini-measure natin? So, what to measure? First, usually sa industrial setup, we would like to measure yung mga fluid pressure. Importante ang fluid pressure sa industry or sa processes. Okay, so next, minsan gusto nating sukatin ano yung mga fluid flow rate, no? Um, of course, yung typical dyan, yung temperature ng isang object, gusto rin natin makuha yan. We want to measure and control yung temperature ng isang object, fluid volume ng fluid na nakastore sa isang vessel, gusto rin nating ma-measure yan. Sometimes we want to measure yung concentration ng mga chemicals, no? And included na rin dyan yung machine position, motion, and or acceleration, dimensions ng isang object, minsan gusto natin sukatin yan, count ng mga objects, or yung tinatawag nating inventory. And lastly, nagme-measure din tayo ng mga electrical voltage, current, and resistance. So once we measure the quantity we are interested in, we usually transmit a signal representing this measurement, itong mga mini-measure natin, to a particular indicating or computing device na kung saan tayong humans or yung computers maiintindihan nila. And kung saan itong device na to will take actions base dun sa measurement na nakuha natin. Okay? So if yung controlling action is automated, so yung computer ang magsisend ng signal to the final controlling device na nag-i-influence dun sa quantity na mini-measure natin. So, what is instrumentation, what to measure. Ngayon naman, ano ba yung mga device na kinokontrol natin? What are we going to control? Usually, sa industrial setup, we want to control yung mga valves, no? Open or close. Yung mga valves para makontrol natin yung fluid. We usually want to control yung mga electric motors, yung movement ng mga motors, and yung mga heating devices. Okay, yung electric heaters. We want to control. Sila yung mga usual na final control device sa isang industrial setup or process. So parehas yan, yung measurement device and yung final control device, they are connected to some physical system na tinatawag nating process. So ano ba yung process? No? So ito, meron tayong illustration dito kung paano natin ini-illustrate yung process or ina-associate yung process dun sa ating mga measuring device, sa final control device, and yung meron tayong controller. So, yun yung kanilang relationship. So, pinaka-common dito na example, kung meron kayong air conditioning unit sa bahay, meron niya tinatawag na thermostat. So, siya yung nagme-measure, siya yung pinaka-measuring device natin. Um, si thermostat, di ba? Siya yung nagsisense. Ano na ba yung temperature ng room? No? And then, ang gagawin niya is, ibibigay niya yung na measure niya na temperature, no? Which is yun yung nasa process natin. Ang gusto natin, palamigin natin yung room. So, ang kailangan natin ma-measure dyan yung temperature. So, ang ginagawa ng thermostat, usually meron yung dalawang functions. Okay, first, it senses, and next, it controls. Kasama sa function ng thermostat is to control. Okay? Usually, dito sa Philippines, dahil nasa ano naman tayo, tropical country or medyo mainit, bibihira yung gumagamit tayo ng heater sa bahay. Pero sa ibang bansa, hindi lang pagpapalamig ang ginagawa ng air conditioning unit. Pwede ring magpainit or mag-add ng heat. Kung masyado malamig yung temperature, pwede ring mag-add ng heat yung air conditioning unit ng isang bahay. So, meron niyang controller that decides kung ano yung gagawin na action, no? Depending on the value or the measured quantity ng thermostat, it will decide on how to maintain yung ating air temperature para maging komportable base doon sa preference ng ating user. Okay? It's either palamigin niya or painitin niya yung heater, no? Or yung paandarin niya yung compressor. So, yun yung ating final control device. So, ang ginagawa niya, it influences. Itong final control device, it influences yung ating process para mabago yung ating measured variable. Okay? So, ang job ng control system, nitong example natin, is to actually maintain the air temperature at some comfortable level. So, kung meron tayong heater or yung air conditioning natin, it will take action to correct, no, para ma-maintain yung correct temperature at maabot yung tinatawag nating desired value or usually what we call set point. Okay, so medyo familiar na kayo dyan dahil na-discuss na yan sa inyo sa feedback and control systems. So itong subject natin ng instrumentation and control, kailangan natin ng konting background sa feedback and control systems para mas ma-appreciate natin yung mga topics. Okay? So industrial measurement and control systems have their own unique terms and standards. Okay? So kaya naman, i-project ko lang dito kung ano yung mga terms na usual na ginagamit sa industry. Para pag lumabas kayo sa industry at let's say gusto niyo pumasok sa mga manufacturing processes, no? Gumagamit nitong mga common instrumentation terms, hindi kayo maninibago. Okay? First, let's start with the process. Ano ba yung process? Process is the physical system we are attempting to control or measure. For example, water filtration system, moth casting system, no? Metal casting system. Meron tayong minsan steam boiler, oil refinery unit, or yung mga power generation unit. So, those are some examples ng process. Okay? Again, the process is the physical system we are attempting to control or measure. Next, may encounter ninyo yung term na process variable or PV. Okay? It is the specific quantity we are measuring in a process. Okay? Ano yung example ng mga process variables? First, pressure, level, temperature, flow. Electrical conductivity is a process variable. pH can be a process variable as well. Position, speed, and vibration. So ilan lang yan sa example ng mga process variable na mini-measure natin sa isang process. Okay? Next, set point or SP. Sorry, SP ano? Itong set point, it is the value at which we desire the process variable to be maintained at. So yung kanina, dinefine natin yung process variable. Ito yung mini-measure natin. Yung set point naman, ito yung value na kung saan gusto nating ma-attain ng process variable. Gusto natin ma-achieve ng process variable. In other words, ito yung target. No? Ito yung target value ng ating process variable. So, may encounter nyo rin yung tinatawag nating primary sensing element or PSE. So, a PSE is a device directly sensing the process variable and translating that sense quantity into analog representation. Again, itong PSE, ito yung directly na nagsisense ng ating process variable. Also, it translates yung na-sense na quantity into an analog representation. For example, ano yung analog representation yan? Electrical voltage, current, resistance, mechanical force, motion. So ano yung example ng mga primary sensing elements? So thermocouple, thermistor, Bourdon tube, microphone, potentiometer, electrochemical cell, and accelerometers are examples of primary sensing elements. So next, transducer. So ito medyo familiar na kayo dito sa transducer. A transducer is a device converting one standard instrumentation signal into another standardized instrumentation signal. Okay? So medyo technical yung ating definition na to. And or performing some sort of processing on that particular signal. Okay? So sa industry, meron tayong tinatawag na let's say a pneumatic signal, no? Or may encounter niyo yung IP converter. Ano ibig sabihin ng IP converter? So may encounter niyo yung IP converter. Anong ginagawa niyan? Converter. So it converts a 4 to 20 milliampere signal, no? Papunta sa 3 to 15 PSI. So electrical. Electrical kasi yung 4 to 20, no? And yung 3 to 15, yan naman ay pneumatic. So, hangin naman siya, no? So, yan yung ilan sa mga klase ng converter or transducers na may encounter ninyo sa industry. Meron ding kabaliktaran, no? PI converter. So, ito namang PI converter from pneumatic papunta naman ng electrical. Okay? So, pag sinabi nating transducer, di ba? A device converting one standardized instrumentation signal into another standardized instrumentation signal. So yung standardized natin dito is katulad ng electrical, standard 4 to 20 milliampere signal. And then yung sa pneumatic naman, standardized 3 to 15 PSI pneumatic signals. So in general science, so pag sinabi nating transducer kasi, it is any device converting one form of energy into another. So example niyan, microphone. Pag nagsalita tayo, nako-convert yung boses natin papunta sa electrical current or electrical signal. So, ganun din dito sa industrial instrumentation. We usually uh, differentiate yung primary sensing element sa mga transducers. So, magkaiba yung purpose nila, no? Yan. So, ang purpose ng primary sensing element is to sense yung yung process variable and then ibigay magkaroon ng output na nasa standardized signal, no? Ang transducer naman is just to convert a standardized signal into another standardized signal. So medyo magkaibang bagay yan. Next, we have transmitters. A transmitter is a device, no? Medyo iba to sa communications engineering. Sa instrumentation terms, a transmitter is a device translating the signal produced by a primary sensing element into a standardized instrumentation signal. So, para ba yan? Ano example niyan, no? An example niyan is, meron tayong 3 to 15 PSI, no? Sa air pressure. Then, meron tayong 4 to 20 milliampere DC current. Then meron din tayong tinatawag na field bus digital signal. So, ang transmitter, ang trabaho niya, it translate yung signal na napoproduce ng isang primary sensing element na dinadala yan sa isang indicating device or controlling device. Or pwedeng indicating controlling device. No? So, yun ang trabaho ng transmitter. So, may encounter nyo pa yan as we go along dun sa subject ng instrumentation. Okay? Next term is a lower range value. No? So, abbreviated as LRV, minsan upper range values. These values of process measurement usually from 0 to 100% of a transmitter's calibrated range. So, yung transmitter natin, nina-assign na natin yan ng 0 to 100%. So, yung LRV natin is 0%. And yung RUV natin may be 100%. For example, if a temperature transmitter is calibrated to measure a range of temperature starting at 300 degrees Celsius and ending at 500 degrees Celsius. So yung LRV natin or yung ating lower range value would be the 300. And then yung upper value natin, upper range value or yung UPB would be yung 500 natin. Okay? So hindi tayo nag-start 0, 0, hindi ganun. So depende yun sa device or yung sa instrument, sa range ng instrument na i-calibrate natin. Okay? So, dahil meron tayong LRV and up UPB, we also have zero and span. Ano ba yung zero and span na tinatawag natin? So, it is alternative descriptions to LRV and URV for the 0% and 100% points of an instrument's calibrated range. So, alternative descriptions. Zero refers to the beginning point ng ating instrument's range. So, walang pinakaiba yan sa LRV. And yung span, ito naman refers to the width or yung difference ng ating upper minus lower. No? For example, meron ulit tayong temperature transmitter and it is calibrated to measure a range of temperature starting from 300 and ending to 500. Di ba? So, temperature natin, 300 to 500 degrees Celsius. So, sabi natin, yung LRV natin, equal yan sa 300 degrees Celsius and then yung upper range pala to, no? Value is equal to 500. So, yung zero natin, zero would be yung 300, of course, di ba? And then yung ating span, it is yung width. So, 500 degrees Celsius minus 300 degrees Celsius equals 200. So, yung ating zero would be 300 and yung ating span would be 200 degrees Celsius. Okay? So, magkaiba yung ating URV or yung upper range. Yung upper range natin is the 500 degrees Celsius. Alright? So, next term. Next term, controller. Controller is simply a device receiving a process variable signal, okay, from the primary sensing element or minsan transmitter, and it compares, no, itong controller, kino-compare niya yung signal na na-receive niya to a particular desired signal. So, yung desired signal natin again is the set point. So, once na ma-compare niya yung set point and yung primary or yung signal na nanggaling sa primary sensing element or transmitter that we call process variable, so gagawa siya ng mga calculations. Kina-calculate niya yung appropriate output signal value na bibigay niya sa final control element. No? So yung value na yun yung magpapa-actuate or magpapagalaw dun sa ating final control element para ma-achieve natin set point. Okay? So, let us define naman yung final control element. Final control element or FCE is a device receiving the signal output by a controller to directly influence yung process natin. Ano mga examples ng FCE? So, motor, variable speed electric motor, meron tayong control valve, and electric heaters. Ilan yan sa mga final control element na meron tayo. Last two terms, manipulated variable or yung MV, it is the quantity in a process that we adjust or otherwise manipulate in order to influence yung process variable. So, minsan it is used to describe the output signal generated by a controller. So, yung signal na nanggagaling sa controller papunta sa final control element, we call it the manipulated variable. Okay, hindi na siya yung process variable. Kasi yung process variable, it is from the primary sensing element or from the transmitter going to the controller. So once na lumabas na yan ng controller, we call it the manipulated variable. Okay? It is used to influence yung ating final control element. Okay? So, last term, meron tayong automatic mode or sama na rin natin dyan yung manual. Okay, manual mode. So when a controller generates an output signal based on the relationship of the process variable and the set point, ang tawag natin doon, automatic. So, si controller na yung bahala. Pag manual mode naman, when the controller's decision-making ability is bypassed by a human operator, so manual na yan. So kahit na nasa-sense niya yung or nakikita niya yung process variable, pero binabypass naman ng human operator yung manipulated variable na binibigay niya sa final control element, manual mode ang tawag natin doon. So, in the next few slides, we will explore some practical examples ng measurement and control systems para magkaroon kayo ng better idea pagdating sa mga fundamental concepts ng instrumentation and control. So, next. Yeah. For example, we have here an illustration of a boiler water level control system. So, kung familiar kayo sa boilers, marami yan sa manufacturing plants, no? Sa industry, usually gumagamit tayo ng steam boilers kasi yung steam is very useful. Maraming gamit yan. Common uses ng steam sa industry, nagpapagalaw yan. It does mechanical work sa mga steam engines, di ba? Sa mga machine. Yung steam din, ginagamit din natin sa heating. No? Meron tayong sa mga garments, ginagamit natin yung steam pamplansya. No? And then, ginagamit din natin yung steam sa pag-generate ng vacuums. Tinatawag nating steam ejectors. Sa chemical naman, usually ginagamit natin yan to augment yung mga chemical processes. So for example, we would like to reform yung mga natural gas into hydrogen and carbon dioxide. Kailangan natin yung boiler or yung steam. Okay? Yung process ng paggawa ng steam, simple lang yan. Pakukuluan lang natin yung tubig, meron na tayong steam. Okay? So, ganun lang siya kasimple. Pero, sa industry, medyo komplikado siya. Kung mapapansin nyo dyan sa illustration natin, yes, madaling magpakulo ng tubig. Kahit sino naman siguro sa inyo, nakapagpakulo na ng tubig. Ano ang nagpapahirap sa boiler system? Ang medyo komplikado kasi na i-achieve natin is to make steam continuously. Medyo mahirap na yan. Kaya nating magpakulo ng tubig, pero yung continuously boiling water at the desired temperature or yung desired level, medyo komplikado na siya, di ba? So, isa sa mga pinaka-importanting variable na dapat ma-measure natin is yung level ng tubig, sa drum. Okay? So, sa isang boiler system, meron kasi tayo dyang steam drum. Okay, yan. Ito yung example niya. So merong tubig dyan sa loob, then yung ibang part dyan, steam. No? Yung ibabaw ng water, steam. Ito yung kinukuha natin papunta dun sa processes. Okay? In order for us to safely and efficiently produce a continuous flow of steam, kailangan ma-ensure natin na dapat level yung tubig or hindi kulang, hindi rin sobra. So pag kulang kasi yung tubig, pwedeng ma-dry natin yung drum uh, at yung mismong drum yung susunugin natin. Okay? So delikado 'yon. Pag masyado namang maraming tubig dun sa drum, ang problema, mamasa-masa yung steam natin. So, sasama siya dun sa process. Ayaw natin mangyari yun kasi marami siyang sisiraing device. So, kailangan nasa level yung tubig. Okay? So, yung first element, so ang objective natin is to actually maintain the level. So, ang first instrument na mapapansin natin dyan is itong LT, no? Hindi to lap trip, no? Itong LT stands for level transmitter. Okay? Level transmitter. Ang trabaho ng level transmitter is to sense yung level ng tubig sa loob ng steam drum and transmit o magre-report siya nung na-measure niya na yon papunta sa LIC. Okay? So yung LIC is called the level indicating controller. So kung mapapansin natin yung symbol dito, parang straight line siya na merong dalawang guhit. So it represents na yung ating connecting signal from the level transmitter going to the level indicating controller is a pneumatic o PSI yung kanyang measurement. So hangin pala ang dumadaan dyan. A variable air pressure is sent through metals or minsan plastic tubes papunta dun sa ating LIC. Okay? So pag mas maraming water level sa drum, mas mataas yung kanyang output dun sa level transmitter. So ito namang AS, so dahil hangin yan, kailangan may supply ng hangin, di ba? So yung AS, yan yung air supply. Air supply. Yan. Okay? So, meron tayong level transmitter papunta sa LIC. So, itong pneumatic signal na pinadala sa susunod na instrument, yung LIC, ang purpose ng instrument na to is to compare yung pinadalang signal ng LT versus dun sa ating desired water level. No? And itong controller, siya na mismo yung nag-adjust. Pwede rin, although pwede rin manual, no? Manual mode. Pwede rin operator mag-adjust, pwede rin yung controller mismo yung mag-adjust. And dahil pneumatic signal to, so yung ating LIC dito, kailangan din niya ng AS or air supply para gumana. Yung output ng ating LIC, which is another 3 to 15 PSI control signal, ito yung tinatawag nating manipulated variable. No? Manipulated variable. Yan. So 3 to 15 PSI signal din yan na pinapadala natin dun sa ating final control element. In this case, yung ating final control element is yung ating air operated control valve. Okay. So, ayan. Itong ating control valve na to, siya ngayon yung magbubukas-sara dun sa ating feed. So, yung tubig, siya magko-control or siya yung magbubukas para ma-influence yung flow rate ng water papunta ron sa ating boiler. So, pag na-sense niya, bumababa yung water level, papadala ni LT sa LIC. Sa LIC naman, ko-compare niya yung signal, papadala niya ng signal tong control valve. Si control valve yung gagalaw para either tumaas yung feed water or bumagal. Okay? Para makontrol yung ating signal or yung ating steam. So, when the controller is placed in the automatic mode, bahala siya kung anong gagawin niya, no? So, depende dun sa sinet sa SP, yung ating set point, magdedepende doon yung magiging signal. So we have here three tables. So dito sa una, transmitter air signal pressure to drum, steam drum water level. So minsan naisipin natin, dahil 3 to 15 PSI yan, ideally, we would want na pag 3 PSI, 0 or empty yung ating steam drum water level. Pagka 15, pag 6, 25%, 9, 50%, 12, 75%, 15, 100% or puno. Pero in reality, hindi ganyan. Hindi natin gugustuhin na ma-empty yung ating steam drum dahil masisira. Hindi rin natin gusto na umapaw, di ba? So usually, sa industry, medyo realistic na values, ng calibrated values ng ating level transmitter, pag 3 PSI, ibig sabihin 40. Example lang to ha. Na usual lang ginagamit natin, pag 3 PSI ang pinadala natin sa LIC, it shows or indicates na yung laman ng ating steam drum 40%. Pag 15 naman, nasa 60%. So naglalaro lang yung ating process variable from 40% to 60%. So yun yung ating zero and span, no? Zero and span. Or sorry. Yun yung ating LRV and URV. Okay? Lower range value 40%, upper range value ng ating process variable is 60%. So yung ating span actually is 20%, right? So, ayan. Doon naman sa valve, no? Pwede ring magpadala ng 3 to 15 signal si LIC para makontrol yung ating valve position. In this example, yung 3 PSI signal pag pinadala ng controller, it means na 0% open. So, isasara niya. Pag 50 naman, 100% fully open. So, meron din mga applications in which baliktad, no? So, let's say 3 PSI yung pinadala, fully open naman, 100% fully open. Pwede rin kasing ganun yung settings ng ating control valve. Pwedeng ganun, no? Depends kung paano siya na-design and para saan. May mga applications na kung saan gusto natin ganun. Baliktad siya. Okay? So, yan yung isang example natin na control system. No? You will encounter many symbols. Symbols na ginagamit natin sa instrumentation. No? And they are part ng pag-aaral natin to learn or discuss yung mga standard symbols na ginagamit sa instrumentation and control. Kasi sa industry, importante na standardized para pag iba yung nagbasa, mas naiintindihan ng lahat. Okay? So next example is wastewater disinfection. So, importante rin to. The final step in treating wastewater before releasing it to the natural environment is to kill harmful substances or microorganisms. For example, yung bacteria and viruses. So, ang tawag natin doon sa process na yon is disinfection. And best or isa sa pinakamagandang disinfecting agent is yung chlorine. Okay? Chlorine gas. However, no, lagi may however to. Hindi rin maganda na masyadong konti yung ilalagay natin. Hinahalo kasi natin yan. Yung chlorine gas, hinahalo natin dun sa ating wastewater para ma-disinfect. Pag masyadong konti yung ating chlorine na inihalo, hindi natin syempre madi-disinfect completely yung ating wastewater. Pag masyado namang marami yung nilagay nating chlorine, baka naman pasama pa at baka ma, ma-poison natin yung mga beneficial microorganisms sa natural environment. Kaya, napaka-importante ng wastewater disinfection process na dapat tama yung chlorine supply. So, to ensure na tama yung ating chlorine injection dito sa process na to, so meron tayong control system, di ba, na gagamitin. So, paano ba natin mini-measure yan? So, meron tayong dito sa example natin, meron tayong uh, dissolved chlorine analyzer. Okay? To measure yung ating, ito yan So, meron tayong analytical transmitter. Ito yung ating dissolved chlorine analyzer. It measures the chlorine concentration sa ating effluent. Okay? And use a controller. Yung signal na yon, papadala niya sa analytical indicating controller to adjust yung position ng motor. No? Itong valve natin na to, it is a motor operated. So, itong M symbolizes motor. Motorize yung pag-open and close ng ating valve, yan yung nag-i-influence dun sa supply ng chlorine. Okay? So, let's say, itong 4 to 20 milliamperes measurement signal ng ating analytical transmitter, pinadala yan sa analytical indicating controller. Itong controller na to, it compares yung ating process variable dun sa ating set point. At nagpapadala din ulit ng 4 to 20 milliamperes control signal sa valve. Yung valve yung ating final control element, which controls or influence yung ating chlorine supply sa mixer. Okay? So, ganyan lang siya. Ganyan siya. Medyo mas simple siya kumpara sa boiler system, di ba kanina? And ito yung process variable natin dito. Isa pa lang. So, makaka-encounter tayo na mas marami pang mga mas maraming process variable sa instrumentation. Okay? So, kung mapapansin natin dito, yung mga bagong nakikita ko dito is meron tayong dash line, no? Di ba? Dash line. Kanina kasi puro solid line. Or merong pneumatic signal, di ba? Itong dash line, ito naman is electrical. Digital actually. Yan. Although parehas lang sila ng silbi ng kanina, ng pneumatic signal, pero yung ginamit kasi nating signal dito is electrical. So, yan. So, meron ulit tayong tables dito, no? So, example lang natin sa transmitter side, 4 to 20. Dito sa example natin, it represents 0 to 100 percent ng concentration. Sa controller side naman, papunta sa ating control valve, yung 4 to 20, it represents yung 0, fully shut, then fully open na valve position. Okay? So, medyo kailangan nyo lang pansinin dyan yung mga ginagamit nating symbols. So, yung mixer ganito, right? Yung process variable natin usually, solid line yan. So, ito tulad yan. Solid line, di ba? Then, visible line lang yung iba. Okay? Then, this is an electronic signal. Final control element. Process variable. Okay? So, ganun lang siya. So, another example. Chemical reactor temperature control. Ooh. Sometimes, meron din tayong na-encounter na diversity of instrument signal standards sa isang control system. So, katulad na itong example natin na to, na chemical reactor temperature control. Meron tayong three different signal standards conveying information. So, ano-ano yung mga ah, standard signals na yan? Yung una, meron tayo diyang pneumatic, no? Pneumatic signals. Then meron tayong electronic or electrical. Then meron din tayong digital, no? Digital. Ito may mga diamond shapes diyan. Yan yung field bus or digital measurement signal. Okay? And then meron din tayong, air supply dito. Ito yung process variable. So, ano bang purpose nitong chemical reactor temperature control? The purpose of this control system is to ensure na yung chemical solution sa loob ng ating vessel or reactor is maintained at constant temperature. So, of course, if we want to maintain a constant temperature, usually sisimulan natin ng pag-analyze yung ating temperature transmitter. Diba? Ito yon. Temperature transmitter, nakakonekta yan sa pinaka-ilalim ng ating ah, reactor. So ito, ang symbol ng reactor is jacketed vessel. No? Ganyan, jacketed vessel. So nakakabit yung ating temperature transmitter dyan. And it sends a digital electronic signal we refer to as field bus papunta sa TIC or yung ating temperature indicating controller. Okay. So ito namang TIC, magsisend yan sa uh, yung ating transducer, no? Ng 4 to 20 milliampere. So yung IV transducer natin, temperature transducer, converts yung ating 4 to 20 papunta sa 3 to 15 PSI control signal. So, ibig sabihin lang dito, yung ating TIC or yung temperature indicating controller natin, hindi siya pneumatic. Kaya gumamit pa tayo ng transducer para ma-convert muna natin yung 4 to 20 papunta sa 3 to 15 PSI control signal bago yan pumunta dun sa ating final control element, yung ating yung ating valve, no? So, ibig sabihin ng TV, yan. Ibig sabihin yan, temperature control valve. Ibig sabihin, depende sa signal na to, na 3 to 15, yun yung magiging position ng ating valve. Ibig sabihin ng ATO, ano yan, air to open. Yan ang ibig sabihin air to open. Ano ibig sabihin ng air to open? It refers to the direction of this valve mechanism as more signal is applied to the actuator. So habang tumataas yung ating control signal, mas bumubukas siya. So yun yung ibig sabihin niyan, no? ATO. So yan. Then another signal na mini-measure dito, yung pressure ng vessel. Importante na ma-maintain din yan. Pero yung main focus kasi natin is yung temperature side, no? Okay? So, meron din tayo ditong pressure transmitter na wireless. So, ito yung symbol ng wireless transmission. So, parang alon-alon. Papunta yan sa PIR, Pressure Indicating Recorder. So, kung mapapansin natin dito, meron yung mga parang mga dash line. Ay, yung bilog niya merong guhit. Pag-aralan din natin yan mamaya kung ano yan. Pero hindi ko na lang muna sasabihin kung ano ibig sabihin ng bilog na merong guhit. Okay? Tapos, merong bilog na walang guhit. Okay? So, let's move on to the next example. Meron pa ba? Yan. So, we're almost done. So, ito lang yung mga other common instruments. So, ito yung mga indicators lang naman ito. We will discuss this some other time. Ito mga indicators. TI, temperature indicator, temperature transmitter. Merong may mga application na kung saan kasi inihiwalay natin yung indicating function dun sa transmitting function. Like for example, itong example natin ng nuclear reactor. Hindi naman po pwede na nandun din tayo sa malapit sa nuclear reactor na may indicator. So, inihiwalay natin yan. So, ganyan. So, ito is another type ng indicator. So, digital. Ito naman, meron din siyang line na ganito. Aside from having digital display, meron din siyang ganito. 0 to 100%. Okay. Then next, meron tayong mga recorders. Ito, siguro di na kayo nakakita nito. Pero ako sa planta, nakakakita pa ako nito. May ganitong bilog. Okay. Ang very common na sa atin yung mga digital display. No? Yeah. So, hindi ko na muna sila elaborate. Pero ginagamit din natin sila sa instrumentation. Okay? So, to summarize, actually, ano lang naman, study ng instrumentation is fun. No? Para tayong doktor na nag-aaral ng mga instruments tsaka kung paano sila paggaganahin para mag-measure and mag-function ng control. So, yung mga terms na diniscuss na rin natin kanina, so, importante yung basics ng instrumentation and control. Kasi bilang mga instrumentation engineers or instrumentation technician, kailangan ma-maintain natin yung safe and efficient operation ng industrial measurement and control systems. So yung career sa instrumentation and control, kailangan dyan very broad yung ating technical skill. Hindi lang kung electronics engineer, electronics. Kailangan meron din tayong knowledge na kaunti, broad yung knowledge natin sa mga pneumatic, hydraulic, and electric. So yung instrumentation is more than just physics or chemistry kasi kailangan yung bilang instrumentation or instrument technician or instrument engineer, marami tayong alam sa mga process variable. Ang importanteng maalam tayo sa process variable para mas maintindihan natin siya, paano natin i-measure at i-control. Okay. So sa mga susunod na lessons, mas mag-focus tayo sa pag-analyze, paghihimay-himay ng mga process variables. Okay? So, let's say we will focus on the pressure measurement, pressure transmitters, pressure indicating and recorders. Then we will go to the next process variable, which is yung flow. Then we will go to the next process variable like level and then temperature. So, kumbaga yung ating study ng instrumentation will be structured according to the process variable na mini-measure. Okay? But then, before we go on to that, dito muna tayo sa introduction, then yung mga documentations, anong ginagamit. So, in the next lesson, we will discuss yung mga instrument documents na ginagamit natin sa instrumentation, sa industry, sa actual na practice. Okay? Sana meron kayong mga natutunan sa lesson natin ngayon at maraming salamat sa inyong pakikinig. Maraming salamat. Thank you.